Of course, I've known you for so long. I'm so honored to be the first one here. I've seen.
So, yeah, why don't you introduce yourself?
I'm one of the founders and CEO of ChipStack, where our mission is how do we reduce how much time and effort it takes to build very complex chips. First of all, I think there's been never a better time to be a chip designer. Get depth in the world of chip design and use AI powered tools like ChipStack, use QuickSilicon like platforms to learn much better at it. Uh,
Hey, Kartik, welcome to the podcast. And yeah, I'm so happy that you agreed to do this. And you're the first podcast guest here. So, congratulations on that. And thank you for accepting my invite.
Of course, I've known you for so long. I'm so honored to be the first one here. I've seen Silicon grow, so super cool.
Thanks. Yeah, thanks about that. So, yeah, why don't you introduce yourself and, just tell us, like, what are you doing? And, yeah, all about your experience. Mhm.
Yeah, my name's Kartik. I'm one of the founders and CEO of ChipStack, where our mission is how do we reduce how much time and effort it takes to build very complex chips. Chips are very close to both of our hearts, and we've been in this industry for a while. But as you know, it takes multiple years and hundreds of people to build a complex chip, and it's only going up because we haven't really innovated in how we build a chip. And
Right.
our mission at ChipStack is to bring in the latest advances in AI in key bottlenecks in the chip design flow. Specifically, we build AI-powered agents that go in key issues such as verification, design, power, performance area, and so on, and help users go much faster than they used to before. Um, my background, I started my career as a chip designer,
Yep.
which was a fun journey during which we met. Later, I shifted my focus more on AI research, kept my connection with the hardware world throughout that. I've been fortunate to work very closely with industry partners during my PhD, whether it's NVIDIA, Meta. Post my PhD, I decided to start ChipStack. I can talk more about that later. But
Sure.
yeah, my life has been some of engineering in chip design, some academic research and AI, then later back all the way to chip design again.
Yep, that sounds very interesting. I think you're one of those persons who have actually, gone deep inside into chips, then, went deep inside into ML, all of the AI world, and now you're trying to combine both of it together, which is awesome. So, we'll be talking a lot more about ChipStack later, but I wanted to first, touch upon how we both met at Arm. So I still remember that we both joined together as part of those graduates freshly out of our undergrad, and the first job we got at Arm, and well, it was a fun experience. And I think amongst all of us, one of the things which stood out was the upcoming global graduate conference at Arm. Do
Yeah,
you remember that?
yeah. I mean, ARM, I think, is a really interesting and a really good company to begin
Yep.
as a graduate.
Yep.
And I think the cohort we had was pretty good as well. And we were
Right.
kind of spread across, CPU systems, uh,
Hmm.
and yeah. So I think the whole global graduate conference was great. That's where I think all of us bonded further. I mean, I wouldn't forget the extra few days we took to explore
Oh,
the
yes. Yeah. So I still remember that on our return journey from, from UK back to India. So we all had separated into different groups. We were doing all our own thing. And then eventually we all met at Heathrow Airport, and, stuff was happening. Somebody was buying this, somebody was packing their bags and things like that. It was crazy. And I still remember that, our flight, it was probably via Chennai back to Bangalore. And at Chennai airport, we
Oh,
got lost.
yeah, it was an insane
Yeah,
experience.
right.
So for us, we were on this trip somewhere in Ireland, I remember, and it rains like crazy there when it
Yep.
rains. And we were on this hill, and the driver is like, "Guys, we might not go back today." We're like, "If we miss the flight, we're screwed for the whole journey back."
Right.
And somehow we made it back. Crazy
Yeah.
fun times. Apart
Crazy
from
experience. Yeah.
just that, I think ARM was a really good experience for both of us. I think.
I agree on that. So I ended up spending what 6 years there, and it was all fun. So I learned a lot, and it actually helped laid a very strong foundation to where I am right now. And all credit goes to ARM, I would say.
Yeah, yeah.
So yeah. So talking more about that, I remember that at ARM you were able to get yourself involved into a AI chip or a very early version of that. So
Yeah.
tell us something about that, like whatever you can share.
Yeah, I think that was a transformative experience for me. So if you remember, I was doing system verification in the beginning,
Correct.
and as I delved deeper, I got to learn a lot, especially on the GPU side. And as I
Mhm.
went deeper into the GPU side, I realized more about general purpose compute power of GPUs and how ML algorithms are running on GPUs right now. And to me, it was very clear that ARM was a very low power processor company. Machine learning inference on the edge was going like this at that time. This was around 2015 or so.
Right.
So to me, the future felt very clear then that ARM had to build a very low power ML accelerator. So I somehow got behind some guys in ARM research saying, hey, we should do this. And they're like, maybe. And then I took some time to, on the side, to build a very basic convolutional neural network accelerator. And I'm like, hey, guys, look, this actually takes only like 10, 20,000 gates, and it can actually do this. And they got interested. And
Mhm.
actually, again, that was beauty of ARM. So
Right.
the systems group then kind of sponsored my unnecessary venture into ARM research to go build this thing called Drishti. We called it Drishti because
Yep.
it was doing image inferencing.
Mhm.
So we built a really cool thing where in the beginning we built an architecture. So the whole idea of how should data flow inside an ML accelerators was something I explored. My manager's name was Vikas Chandra. He was at Arm Research then. He
Right.
was awesome mentor, and then we together built an awesome prototype. It took I think less than 10 milliwatts of power.
Oh
Uh,
wow.
uh,
Mhm.
and then we presented that as a global engineering conference. And a few years later, I looked back at ARM's NPU product, and
Mhm.
I was so happy to see uncanny similarities between the original architecture of Drishti and how kind of it had influenced the ARM NPU journey.
That
So
is great. Yeah, I mean that's a great validation of your work, right?
most
Yeah.
proudest achievements I have
Yeah.
because our NPUs are now almost in every SoC.
Yep.
So building that was fun, like architecture, design, verification,
Mm.
physical design of a very small piece of processor. But that's great.
Yep. So I think one thing which you touched upon here was that how you yourself, tried to figure it out and build something to showcase them. So this is something which I always keep on telling, people who reach out to me for advice and something that, hey, if you don't feel happy in your work, just, find something which interests you and go and build it on your side and then showcase it.
So
That always helps.
I 100% agree. I feel like one of the most distinguishing qualities, which today also when we hire, or I'll tell you the first hire we made at ChipStack as well. But I think
Mhm.
persistence and determination just is so key and important, and people respect that. When you see someone someone who strongly believes in something and goes behind it, people recognize it and value it. And also,
Yep.
good things happen with time and persistence, and that you have to
Mhm.
kind of proactively try it.
Yep.
And yeah, I think like for example, the first hire we made, this guy had no background in chip design whatsoever,
Sure.
but just kept coming to our incubator, showing up. Hey, I read this chip war book. That's great. I like what you guys are doing, and he kept on coming. After a few months, I just respected the skills he had, and this was our first hire. Is good.
Yep. So if you guys are looking out for a job, just show up. That's
Yeah,
all.
multiple times.
Multiple times. Yeah. Cool. Yeah. So it's great to know that, your initial work at ARM was still able to make it into the NPU products and all of that. But I still remember that very early on, you had this mindset of, you wanted to do something more than just being at Arm. And eventually, you left out for US and started doing a PhD program there. So like, could you tell us something more about, what did you do? What was your PhD about? How was the experience there?
Yeah, sure. So to me, PhD was definitely not my kind of goal at that time.
Mhm.
And I wasn't actually planning on leaving ARM or anything.
I see.
So I ended up going to ARM Research to build this processor. And as
Mhm.
I did that, and I was surrounded by other folks at ARM Research, all of them had a PhD as well. I could very clearly see one distinguishing quality, which was ability to take a complex problem, think about it methodically, go deep in that topic, and make something really cool. So to me, I thought that quality was very attractive, and
Mhm.
I also realized I just didn't have the depth to do whatever I wanted then. So I asked them, hey, what do you think? Like I really enjoyed the process of building an ML accelerator here, but I don't think there is anything very novel about it. We actually did it, but I want to go deeper and really figure out what are other ways to do it. Are there newer ways to do it? And they said, hey, the only way to do it is to actually go through a PhD program. And then I wasn't so sure. And then uh, my mentor Vikas at that time
Mhm.
kind of laid out the idea of what PhD is, and the way what he said kind of really kind of changed my mind. It is an ability. It helps you build an ability to solve difficult problems in methodic ways. It doesn't mean like people with PhD are the only ones who can do it. It just teaches you that skill and going deeper into a topic. And he wrote me a pretty good recommendation letter, and that really helped me to get into PhD programs. And I
Mhm.
still think it was a great decision to do it.
Oh wow, yeah. So you did it like in 5 years, and it was mostly in computer architecture and what, AI.
Yeah, so I entered the PhD program with the view that I wanted to build next generation ML hardware,
Right.
and I went to University of Illinois at Urbana-Champaign, and
Mhm.
I was the first student of my professor, which was really nice because he actually just sat me with me in the lab. We hacked together, built a lot of things. He
Wow.
cannot do that anymore. Towards the end of my PhD, I mean, he was rarely available for a meeting, but that was really nice to work together that way. My PhD was, I say, it's at the intersection of AI and hardware.
Mhm.
So the work I did kind of touched both aspects of it. It's on the one side, we optimized AI training algorithms and inference algorithms to be more
Mhm.
compute efficient. And on the other hand, with those specialized algorithms, we built specialized architectures that can use that. A good example is we figured out how we can use zeros that are present in an ML model, and then build hardware that can use all those zeros to be more power efficient and much faster than before.
Yep.
And some of those ideas were important in the work we did with NVIDIA on their sparse tensor based hardware. And I hope that influenced some of the decisions they made on their GPU architecture. And similarly with Meta, where we built different versions of recommendation systems. When you go into Facebook or Instagram, it's running hundreds and hundreds of recommendation algorithms. Like, how do you show who should be the first story to show or first
Yep.
post to show? They're all, in fact, like Meta's every day they run 1 trillion inferences of their recommendation algorithms. So how do you optimize the algorithm? Then how do you change the hardware? Um,
Mhm.
and one more way I think about the work I was doing was think about the spectrum of programmability and specialization, right? So we have CPUs that are extremely flexible, can do
Yep.
anything, Turing complete. Then you have like very specialized hardware, where is the sweet spot? Uh,
Mhm.
let me stop that monologue. But in general, intersection of AI and chip design was the PhD focused on.
Wow, I think yeah, you picked the best of both the worlds. I would say you got an experience of AI, you got an experience of chip designing,
Yeah.
and then out of PhD, instead of going like the normal route of picking out a job and growing there, doing research, you started to build your own company. So how was the transition from being a PhD student and then now starting your own venture and growing it out?
Yeah. It was not an easy journey, honestly.
Yep.
It wasn't so. As I said in the beginning, I was an engineer. Then I got to be an academic and kind of get a taste of research labs and being a research
Mhm.
scientist. So I had an urge to try the unexplored one, which was being in a startup. So I somehow managed to get into one of the incubators within the university and work on this startup idea. It was an idea in extracting insights from ML training runs and bring that out to users much easily, like whether your model is converging or not, and all of these. So I was by myself trying to build that, and I did so many customer discovery interviews and built an MVP, put it on GitHub, got 100
Wow.
stars in like a week. I was like, oh shit, this is going to take off. Uh, but but it didn't go that way. But the I really enjoyed that experience of thinking about a new problem, coming up with an interesting solution, and then
Right.
building an MVP and iterating on it. And to me, it was a very interesting mixture of both engineering and research. When
Mhm.
you do engineering at big companies, you'll very quickly lose track of kind of the big picture. The novelty goes down. When you go to academy and do research, you maximize on novelty, but you kind of stop implementing and building things that are very useful to people. Like there is no
Correct.
optimization towards it.
Yep.
Startups bring both together. You have to build something people want, and it has to be pretty novel for it needs to go into marketplace and win.
Yep.
So the mixture of both and the challenge of all the other aspects of building a
Mhm.
business and everything seemed attractive. The first startup failed, to be clear,
Okay.
but that was a fun enough experience for me that I decided I need to go deeper into this. So that's where I then ended up at the Allen Institute for AI, which is
Mhm.
a large research institute in Seattle, but they also have an incubator. And I just walked in. I said, "Hey, I want to build a company. I don't know what, but I want to build one." And they had seen me kind of fail at the previous one. Apparently,
Sure.
first time failure always teaches you better things, and
Yep. Yep.
they gave me that opportunity. So that's when ChipStack came up.
Yep. Yeah. Yeah. So I am a strong believer that every time you fail, you learn something new, and you are kind of like a stepping stone towards a path of success. So failure, I would say that it is inevitable. I think with QuickSilicon also, I had like a completely different idea to what it is now today.
What was the first idea?
Yeah, so the first idea, we wanted to do something like an interviewer friendly platform where you can come and or where companies can use it to actually screen candidates and interview them. And the only additional thing which we were providing is that, hey, when you're interviewing, you could actually ask questions. You can give them a design problem, and then the candidate can come write the Verilog RTL and stuff and run it on the platform. So that's how we were planning to sell it to companies and stuff like that, but nobody entertained us. So they were just like, hey, we don't see the volume. Like, we don't want to do this. Our screening process is good enough. You can just take a look at the resume and that's it. Or do like a phone call. We don't need this software style thing. But, in the process of doing that, a couple of people actually said us, why don't you teach courses here? So
Yeah.
you have like a great platform where you can go hands on. Why don't you do that? So that's when we thought of, hey, let's pivot and launch courses on top of it.
I
So
love it. I love it. I don't think, I don't think anyone kind of gets out of the bed and eureka, I know the best
I
idea
agree.
ever. You see,
Yep.
you just get started, but you have to make calculated bets probably early on based on your skill set, based on the market that you see, and all of that. Once you
I
do
agree.
that, jump in with something, and you'll eventually figure out the path.
Yeah. Yep. Yep. That's true. Yeah. Cool. So yeah, tell us something about ChipStack. So what does it do now, and how's it going for you? How big it is? Are you hiring right now?
Yeah, yeah, definitely. In fact, hiring is the most difficult problem. So when you said there is an interview platform where you can, my ears were out. I mean, there's something of that can be used. But yeah, at ChipStack, we are, as I mentioned in the beginning, our focus is, our North Star is simple. We should be able to build a complex silicon in less than a month with less than 10 people. Uh, I think it's a very achievable goal in the next 5 years with the way AI is evolving right now. But it won't happen overnight. It's going to take multiple years of work, multiple excited early customers, a lot of investors putting faith, people burning midnight oil. It's going to take all of that. But I think in 5 years, that's an achievable target. And when that happens, imagine the new world, right? People
Yep.
can build a chip in less than a month, in less than 10 people. And the number of companies that are going to build a chip is going to be massive. So that's our North Star. And so our current product focuses on verification. So we have different verification focused agents, whether it's formal, in simulation, you have UVM, system Verilog. So we have agents in verification that are capable of doing things autonomously, and can take human feedback in between, but they have access to the environment that a verification engineer has. EDA tools, compilers, parsers, linters, everything that's required that a verification engineer uses is available to this agent. The agent can figure out, by reading the RTL and specification, what is the intent behind this design, and then use that to run through different verification flows, use the right tools required. Um, I'm very proud of what we've built so far. It looks very
Yep.
futuristic. I
I
mean,
I agree on that. So I had the opportunity to try, ChipStack personally, and one of the features which I really love is the documentation. Because hey, as RTL designers, I hate documenting things, and I just told it, document this module for me, like whatever you see, and it parsed out all of the finer details, and they were all correct and technically sound. So I was so happy to see that, and it's like a dream come true for a verification engineer, because they keep on pinging us, hey, how does this interface work, how does that interface work, and ChipStack can do it for you very easily. And I've also had the opportunity to tell it to write assertions for certain modules, and it does a pretty good job at it. So yeah, kudos to you and your team. I think it's definitely a product which a lot of companies should try out. And yeah, I definitely believe that you guys are going to be successful in that. So tell us something more about how does it work? Like, is it like an LLM based product where you take in
That's
all of the information?
first of all, I mean, coming
Mhm.
from you is a big thing. You're a successful designer. Yeah, so the product is, so I look at it as our value proposition is kind of 4 layers. The first
Hmm.
one is task specific fine tuned large language models. We fine tune LLMs to be better at certain chip design focused tasks. In fact, we recently collaborated with OpenAI to use their latest models and fine tune them and show that even on their frontier models, we can get over 10-15% improvement on many chip design related tasks. So the first one is better LLMs that are focused on chip design. Layer number two, what we call it flow engineering. So that is, how do you take a complex problem, break it into smaller pieces, and compose them so that LLMs can reliably solve it. A good way to think about this is, think about, say, a complex program, let's say fast Fourier transform. From an outsider, that code looks like magic, but it actually works under, because it all gets compiled into additions and multiplications
Yep.
that a CPU can always reliably do. So similarly, take formal verification, super complex. How do you
Yep.
break it down such that a large language model can reliably solve those subcomponents? So we are basically doing that job. We call it flow engineering. So task
Sure.
specific LLMs, flow engineering. Third one is the integrations. So I just talked about tools. How do
Mhm.
you build an environment where these LLM based agents have access to all these tools? For example, whether it's EDA tools from Synopsys or Cadence, or parsers and compilers. How do you expose an API that models know how to call and read results from? So all these integrations and infrastructure we build is the third layer. Fourth is user experience. these agents cannot be 100% autonomous, at least today. So humans need to be able to interact with them and give feedback and use it in their real workflow. How do you build a high quality user experience? Chip design tools they look like they've been
Yeah.
in.
Yeah,
They're
they're notorious for their user experience. Yeah, I mean, they just don't care about it, I would say. Yeah.
So the way we went about it is to build a team who do not have. There is no one who has built EDA tools before in our company,
Yep.
and that was important to us so that we don't bring any of the DNA from there. We have software engineers. They use TypeScript, React, and all the modern web frameworks that you can use, and
Mhm.
software engineers on the back end who can use Docker, Kubernetes, and all the kind of cloud native technologies that we can use. So we built the whole platform in a very futuristic way. I mean, it's not futuristic; it's standard in the software world, not so in
Right.
the hardware world. And we have built it that way. So just to summarize, the platform works with customized LLMs, flow engineering, integrations, and infrastructure, and user experience. So all of that comes together to make this happen.
Right. And currently it is for both formal verification and simulation-based test benches, UVM and system error.
Correct.
Right. And
Correct.
are you planning to extend it to RTL also? Like,
Yeah,
or
so design is our next step. So we
Mhm.
consciously made that decision because verification is the inner loop of design, right? When
Yeah.
you come up with a new design, you have to check its functional correctness, or when you improve its PPA, then you have to go back check functional correctness. So once our verification agents mature, the design agent can internally call verification agents to iterate very quickly. And
Yeah.
also, people can trust LLMs on doing verification because you're, after all, testing something. But
Mhm.
the trust factor on it designing an RTL that'll go in a tape out is just the trust threshold is pretty high. So we
Right.
made the choice, and also the bigger bottleneck in a larger chip design flow is always in verification.
That is
So
true.
combining all of that, we chose that to be the beachhead.
Yeah, that's great. So do you have like any user experience stories to tell us that, hey, ChipStack came in, wrote some assertions, wrote some, test bench and found like, some corner case bugs and
Yeah,
things like
so
that?
it's always awesome when a user gives us some experience, and some of them have been, for example, we on a pretty complex design, something that was going to take over 104 hours. We actually did this experiment where we had one engineer with ChipStack, one without ChipStack. Now let's go. Let's do formal verification of this design.
Right.
And the one without took 104 hours. With ChipStack, it came down to 20 to 30 hours or so,
Wow.
without missing any bugs. So both sides found the same bugs. On there was another design where ChipStack found a unique bug as well. So many of these that I can share. It's a pretty you have experienced this when you see someone actually using what you built. It's
Yep.
always a very satisfying feeling.
Yeah, I absolutely agree on that. Till today, if someone comes and tells me, "Hey, I've taken this course on QuickSilicon and I'm enjoying it," I just, that just makes my day.
I love
So
it.
yeah,
Yeah, yeah.
yep, yep.
So yeah, as a company, we're around
Mhm.
15 people and growing. We're
Right.
always looking for smart engineers um,
Mhm.
who want to change the way chips are designed, and have
Mhm.
background in any one of these: chip design, software, or ML. If you have background in any of these, I think it's a fun place to work. And especially because there is three verticals coming together. There are very few places or companies where you can go work where kind of three major things come together. And I think with ChipStack, that's pretty unique. As a company, I always think of startups with four things. So people, customers, people in the sense employees, people, customers, money, as well as product.
Yep.
No order of preference, but we have awesome people involved who in the company, people who have built chips, people who have built large language models, have built really complex enterprise scale products. Also, our investors, Khosla Ventures, and others who are pretty well known. We're glad to have them backing us. In
Yep.
terms of product, I already described what we have.
Mhm.
And in terms of customers, this product is currently deployed at multiple companies, from AI chip startups to Fortune 100 companies building CPUs and networking chips.
Awesome.
We're still in the early stages of this for sure. We are
Mhm.
very consciously limiting how much effort, how many customers we take, because
I
we want to make each one successful. But I think we'll be ready for scale in a year or so when we have proven technology. We want to be sure we've built something reliable, lasting, easy to use. Until then, we were heads down making that
Yep.
work.
That is a great choice, Karthik. And I think I agree with that. Limiting yourself to number of customers, that's the way to grow. And making sure that they are successful with product, that'll actually help skyrocket growth once you get some user feedback to it.
I agree.
So yep. And if anyone wants to reach out to you or apply for a job, like what's the best way to do that?
Yeah, you can go to our website and go to career section. Just drop me an email. I read every email. So Kartik at chipstack.ai also works.
Awesome. Awesome. Yeah, thanks for that. Okay, so now moving ahead, I think a lot of people actually reach out to me where, they have concerns of right out of doing their masters in US, they want to find a job and they are, unable to find the internships in the current landscape or land a job and stuff like that. So what do you suggest one should do if they have done a master's in computer architecture slash electrical engineering and they're looking out for a job? What would your one advice be to those guys?
First of all, I think there's been never a better time to be a chip designer
Yep.
in like forever. I think we are in like the golden era of building chips. So I think having your degree focused on this area is awesome because there is just tons of companies hire, including ChipStack. So there is just so much opportunity out there. I would say just build your network. A lot of these hires happen based on network because these big companies just get so many resumes. How do you figure out which one is good? And a lot of that fall through cracks. So I think the best way to do it is to network, and you can do networking at conferences. You can do networking at other kind of major events that happen. For example, NVIDIA has GTC or AWS has their and so on. So you can network at different places. I think that's usually the best way to find jobs. And also networking is not just saying hi to someone. It usually takes a little bit of effort
I
uh,
agree. Yep.
to actually write someone a meaningful, thoughtful message as to why
Mhm.
you want to meet them. And once you meet them, finding common grounds and continue to work with them. But my suggestion would be networking as the best way to do it. But even otherwise, I don't. I think there's just tons of opportunity out there.
Yeah, I agree on that. And I think one of the points which you mentioned that hits the target, that is there are so many resumes which big companies get and a lot of them just get lost. So how do you think, I agree that networking is one of the ways to do it, but how do you think one person can build their profile so that their resume shines out? My number one suggestion is right now I think chip design thing is, yeah, obviously it's growing and it is the place to be in, but at the same time the open source hardware that has also taken off quite well. Now it was not there when we were graduating out
Yeah,
from our undergrad, but within the last 10 years or so it has grown significantly. And that is, I think, one of my also recommendations to people, that hey, go out there and try to do some open source project or try to do the Google Summer of Code, because now there are a bunch of hardware focused organizations which are there, and that's a great way to showcase industrial level projects on your resume. And also it teaches you a lot of other concepts as to how bigger complex chips get made from a lot of tiny things coming together.
I love that suggestion. So when at least I'm screening resumes, I'm always looking for something that stands out, and usually the ones that stand out the best are hobby projects that are actually very
Yep.
interesting, and usually it tells about the quality of the person and their kind of, I don't know, drive to do something different. Exactly what you said. Go contribute on hundreds of RISC-V projects out there, and actually networking automatically happens if you do that. You
Yes.
will meet people there. So I agree. I think open source contribution slash hobby projects, it doesn't actually have to be just chip design related. Could be adjacent
Mhm.
to it. Could be embedded systems, could be anything related. But that's a fantastic suggestion. I think that's really true.
Yep, yep. Thanks. All right. Now coming back to QuickSilicon, like have you tried QuickSilicon at all? What do you think about it? And yeah,
Yeah, so very early on, if you remember, I got to try the MVP, and it's impressive. So first of all, I think what I love about it is which there is huge industry need, and I would say something it has an inbuilt value that probably is underexplored is the ability to run all of that on a web browser
yep,
in a very easy, high quality user experience. It's awesome. So I think the ability to iterate on something right there is really nice, and someone practicing a problem is just way better. And you asked how to get hired better as well, and usually in hiring process, 90% of our kind of inputs come from coding interviews,
yep,
and it's just listening to people who've done well on coding, and it usually is about thought process. Can someone actually think critically and solve some problems? Even if they get it wrong, can they iterate on it? And I think Quick Silicon, I've seen similar versions in software. There's nothing like it in hardware. So I think someone practicing problems there, learning how to iterate, what mistakes they made, and practice always makes someone perfect. And every time you iterate, you'll realize what mistakes you made. Kudos to you for building that platform, and especially people doing masters here probably can utilize that to prepare for their chip design.
yeah. Yep, thanks for that. I think yeah, that's one of the problems which I was aiming for. That hey, I wanted everything to be hands-on. I wanted minimal theory and everything to be practical, hands-on coding experience. And which is why it took me like more than a year to get the platform out, and just to get the MVP built. And it was crappy back then, but yeah, we have slowly iterated over it over the multiple years, and it is where it is now.
Where does it all run? Is it on some cloud? How did you build the integrations with all the open source tools?
Yeah, so it's hosted on an AWS server today, and which hosts like all of the open source tools also. And then we have our own internal, uh, mechanism of communicating with the website's front end to the open source tools and whatever outputs get produced, and the back and forth communication. And that's where I think the bottleneck also today lies, and which is why sometimes the simulation take little longer than what they ideally should. And this is something which is one of my priorities to fix and give users even a better user experience, that hey, you just click a button and the waveform shows up right then and there. And I think one thing which we really improved on or iterated on over the years was the waveform. We started with a very static, a JPEG based waveform viewer where you can just view it, and then we got something with a JS and something like that where you are able to at least click on a few things and see what is happening. And now finally with an open source project called Surfer, we were able to give a very realistic user experience to as to what is being done in the industry with industrial level tools.
Actually,
So
we have integrated Surfer as well. It's an
yep,
awesome open source. Again,
right.
shout out to Surfer. I think if you want to contribute to something in open source, that's a great choice.
Absolutely. Yeah, you should do that. Yep. Yep. Great. Yeah, it was great talking to you, Karthik. Any final remarks? Anything
Uh,
which you would like to add? Yep.
No, I think as I mentioned, we are in a very special period in our industry.
Mhm.
There has never been a place and time where there were these many organizations thinking about chips. Just to give you an idea, right? If you go back 5 years ago, number of teams building a chip was an order of magnitude smaller. We have hundreds of AI chip startups. Almost every big tech company has not one, multiple chip design
Yep.
projects, and this is only going to grow from here because fundamentally Moore's law has slowed down, which means you have to build specialized hardware. And that essentially means any big company that wants to differentiate themselves on their software product need to build their own custom chips. And with advent of companies like ChipStack, where that barrier comes down, you can only expect this to go up. So I would say there's just never been a better time to enter this. get depth in the world of chip design, and use AI powered tools, use QuickSilicon like platforms to learn much better at it, and then you'll be in a better shape to contribute to this.
Yep. I absolutely agree with that thought. I think, yeah, chip design is to grow. And yeah, and the number of software companies also now getting into chip design, that is also crazy, which signifies that, hey, we're going to get a lot more jobs, a lot more opportunities, and a lot more specialized chips, which is great for the future.
I
Uh, yep. So it was great talking to you, Karthik. Thank you so much for agreeing to do this.
oh,
And yep, have a good day.
You too, Rahul. See you.